Now, let's continue then. Let's look at the connection. Because when we connect a circuit, we can connect a circuit in series, we can connect a circuit in parallel. Then we can play with it and make it both series and parallel, or make it parallel and parallel. But when we connect a circuit diagram, we must make sure that it displays series or it displays current. And I've always asked learners, what makes a series circuit and what makes a parallel circuit? And I would get abstract responses. And learners will tell me about the current that is flowing in different directions, but I'm just looking at the picture. How do I know that this current is flowing in different directions or in one direction for me to say that this is series or this is parallel? So for me to know this is series or this is parallel, I must have concrete evidence of the connection. And for us, or the easier way of seeing that this is a series circuit, it's when we look at the resistor. For us to see that this is a parallel circuit is when we look at the resistor. So resistors in series, they are connected along the conductor. That is a series circuit. Resistors in parallel, they are connected parallel to each other. That is a parallel circuit. So why I'm conscientizing you, even when we do calculations, the first thing or the easier thing to do, it is to calculate the effective resistance in that circuit. So a series circuit connected along the conductor, parallel circuit, resistors, they are parallel to each other. Now, let's start with the series circuit. We are saying that we are compressing everything about electric circuits to three concepts. So we must ask ourselves a question. What is happening to current in series? What is happening to potential difference in series? And what is happening to resistance in series? Let's start with series. And I would motivate you to know one side because you know the other one is the opposite. So in series, let's start with the current. In series, we are saying that the current is the same. This is important. This is important. Now, we are influencing our calculation. In series, the current is the same. Why is it the same? And then I will provide an answer and say it is because the current flows in one direction. So if you are measuring a current of 0.1 amperes here, the current that will be measured here will be 0.1. The current that will be measured here will be 0.1. The current that will be measured here will be 0.1. Why? Because in series, the current is the same. And also, for the benefit of our calculation, the current that flows in series is our total current. So the current that flows in series, that is our total current. So when we want to get the total current, it is the one that flows in series. Now, we've answered the question, what is happening to current in series? The current in series is the same. If we know one side, then we'll know that in parallel, it is the opposite. In series, the current is the same. Let's look at potential difference. In series, the potential difference is divided. In series, the potential difference is divided. So for us to get V external, we'll say it's V of R1 plus V of R2. Why? Because in series, the potential difference is divided. Then, let's deal with the resistors in series. The resistors in series, we use this term, we sum them together. So we add the resistors in series. So Once we have this information about these three people, we are fine. You know, oh wow, if I look at the circuit and I see this is series, I know the current will be the same. The potential difference will be divided. And the resistance, I must do what? Add the resistors in series. Let's look at parallel. What is happening to the current in parallel? What is happening to the potential difference in parallel? What is happening to resistance in parallel? And I motivated you to make your life stress-free. Just know one side. You will know the other one. It is the opposite. So, in parallel, we are saying that the current is divided. So the current that is measured here in series, which is the total current, this current, you can say it's A3, it will be divided to the current of A1 and the current that is read on A2. Why? Because in parallel, the current is divided. Then what will happen to the potential difference across the resistors connected in parallel? We are saying that that voltage will be the same. So in parallel, the potential difference to resistors connected in parallel is the same. And then what will happen to resistance? We'll say 1 over Rp is equals to 1 over R1 plus 1 over R2 plus 1 over R3. If you are having two resistors only, you are allowed to use this formula. Rp is equals to R1, R2 all over R1 plus R2. Now, let's get to the grade 12 stuff. EMF. The first thing is the definition of EMF according to the exam guideline. All our definitions should be centralized to the exam guideline. What does it say? It says that the EMF is the maximum energy provided by the battery per unit charge passing through it. That is the EMF. And then you will be required to solve problems. Maybe this is where I should be more specific. If you are given a circuit diagram, you must know that your destination should be one of the three things. If from the statement you are given the EMF, you will be required to calculate the internal resistance. That should be your destination. If you are given the internal resistance, you will be required to calculate the EMF. That will be your destination. Now they are making life more interesting. They give you both EMF and internal resistance. Then which question will they ask? They will ask you to calculate the total current. I have summarized everything. I'm done. I've summarized everything. So we are saying that if you are given EMF, you must have stress of internal resistance. If you have internal resistance, you must be aware that they will ask you to calculate what? EMF. If you are having both EMF and internal resistance, you will be required to calculate the total current. So you can solve problems using EMF is equals to V load plus V internal. That is why the units they are volts. It's V plus V. So what is this V load? It is the external potential difference. It is the terminal potential difference. Like for instance, as you buy that battery to replace the one battery on the watch at home, the battery is written 1.5 volts. And now we understand that 1.5 volts, it is the EMF. It is the maximum energy that battery can supply. You can solve using this formula. E is equal to I plus I. What is R? It is the resistors that you see from the circuit diagram. And what is the small r? It is the internal resistance found within the battery. So this is the formula of EMF. EMF is equals to I r plus I r. Then you will solve problems. You'll be given a circuit diagram. I told you 4 scenarios can arise from there. A series circuit, it won't happen, I can guarantee you. So you're left with 3. Parallel, series parallel, and parallel. But what I love about the exam guideline, you will be restricted to 4 resistors. Now, here is a nice summary of the EMF that we've been discussing. So from your circuit diagram, when the switch is open, it doesn't mean that there is nothing. When the switch is open, we will have the EMF, which is 10 volts in this instance. When the switch is closed, we don't have EMF, we have terminal potential difference, V load. So when the switch is open, we have the EMF 10 volts. But once you close the switch, some of the energy will be used, it will be lost. Then the one that remains, it becomes your V load, which is equal to 8 volts in this case. And then our V lost or V internal will be 2 volts. So that is why then the formula for EMF is equals to V load plus V lost, which is 8 plus 2, which will give you the EMF, which is 10. So when the switch is open, it reads the EMF. When the switch is closed, it reads the terminal potential difference. This one, I am only interested in the explanation of it, which is number E. So you can look at this circuit diagram. When switch S is open, V1 reads 9 volts. When switch S is closed, our ammeter reads 600 times 10 to the power negative 3 amperes. And then we can ignore the internal resistance of the battery. And it says we cannot ignore it. The battery's internal resistance cannot be ignored. The switch S is now closed. Now, what is happening there? This is an explanation question that you'll find, where they'll ask you, will this thing increase, decrease, or remain the same? And I know you learners will have to say creases. We don't even know what is creasing. It is D or is it E? But you will just say crease. Even the one at the back will say creases. So once you have made a decision that it is decreasing or it is increasing or it remains the same, you must be in a position to provide an accurate answer or explanation to that. And this one, it links to the grade 12 content, and it also links to the EMF. So that is why I'm having that urge of wanting to explain it. Now, the 4 ohm resistor is replaced with the 4 watts light bulb. Here is our 4 ohm resistor is now replaced with the 4 watts bulb. Then, and V2 reads 2 volts. The first question says calculate the new reading on the ammeter. And besides calculating the new reading on the ammeter, I'm interested in the second question. Explain why the voltmeter V1 will decrease when 4 ohm resistor is replaced with the 4 watts bulb. So we can use a formula here. We're having power which is 4 watts. We can also see we're given V, which is 2 volts. We can get R. Power is equal to V squared over R. Our power is 4. Our V is 2 squared over R. Then you can see that our R will be decreased to 1 ohm. So we have proven, that's number 1. But the question is saying, explain why. So now, how to explain? We know that the resistance will decrease. Now we know that the resistance of 4 watts will be less than 4 ohm resistor, which was the original one. So we must link everything to the formula. EMF is equals to I plus I. EMF is equals to V load plus V lost. So if you decrease the R external, this R, what will happen? You are decreasing R external. So your first point, you'll tell us that R external decreases. And when R external decreases, what will happen to the V load? The V load also decreases. Now, because we are talking about R external and V external, they are FME. It's R external and V external. It forces the current to form a coalition with V lost, because V load and R external, they are FME. So if you decrease the resistance, effective resistance in the circuit, we are also decreasing the terminal potential difference. And we are saying that the lower the resistance, what will happen to the current? The higher the current. Then the current will increase. Now, because the current has formed a coalition with V lost, it means also V lost will do what? Will increase. So I wanted to conscientize you with this question. To say, as you explain this question all the time, you must know that R external is related to V load. They go hand in hand. Current will form a coalition with V lost and move in one direction. So when you decrease the R external, you are decreasing the terminal potential difference. And then what will happen on the other side? The current will increase and also the V lost will increase. So here is a matter of partnership. So it is important to remember this explanation all the time. Now we are talking about the calculations. I did say our weapon for electric circuits, there are two. It is the exam guideline and the formula sheet. Why formula sheet, to be precise? Because choosing the correct formula, it's a skill. That's why you get accredited a mark for choosing a correct formula. But you don't get that mark if you don't substitute. You must use that formula. So you'll find a formula sheet that is full of different formulas. When you deal with electric circuits, you must go to the section of electric circuits, because these are your tools that you are going to use to perform calculations. R is equal to V over I. Resistors in series is equal to the sum of resistors in series. Resistors in parallel, 1 over Rp is equal to 1 over R1 plus 1 over R2. But as you use this formula, you must be conscious to flip your answer at the end, because we don't want the inverse of R parallel. We want R parallel. Then you can also use this one. W is equal to VQ. Power is the rate at which work is done. A charge, we can get it from the current formula. And then these are the power formulas. And these are the energy formulas. So as you look into them, power formulas, energy formulas, the only difference is very simple. The energy formulas, they have multiplied by time. So it's power multiplied by time. It is VI multiplied by time. I squared R multiplied by time. V squared over R multiplied by time. So let's make sure that as we perform calculations, we choose the correct formula. It's a skill to choose a correct formula. We can never overemphasize that. To choose the correct formula, it is a skill. It is a skill. Let's make sure that we choose the correct formula. Now, let's get down to it. So, our horror in electric circuits is that along the way, our concentration span decreases. We become exhausted as we perform these calculations. To some, you find them as difficult. I said today, we are providing a cure to that. And we are saying for you to get maximum marks, number one, you must have confidence. We are speaking to the issue of confidence. Don't leave the electric circuit unanswered. Don't leave a question unanswered. Have confidence. You can do it. You can do it. You can do it. Now, I want us to analyze this problem. It says 3 electrical devices X, Y, and Z are connected to a 24-volt battery with internal resistance R as shown in the circuit diagram below. I had indicated to you, when you look at the circuit diagram, if you are given the EMF, you must know that you'll be required to calculate the internal resistance. If you are given the internal resistance, you must know you will be required to calculate the EMF. And we are saying now, if you have both EMF and internal resistance, the question will say calculate the total current. So we are ready. So as you read this question, that's what must come to your mind. We are given the EMF. So whatever that we do, we must reach the internal resistance. That's our destination. The power rating, see now they're talking about power. For the following devices, X and Y, they are indicated. And then the statement will continue and say, with switch S1 closed and switch S2 open, the device function as rated. So I want us to look into this. So S1 now is closed. I'm closing it. And then 2 remains open. So the current will go to X and Y. So you just divide this. You can say here, I'll deal with X. And then here, I'll deal with Y. We are not answering any question. We are analyzing. Because the power of electric circuits, it is for us to analyze and understand the circuit connection. So when you look at this diagram, it tells you that these devices, they are connected in parallel. And remember this topic I said to you, in everything that we do, we must ask ourselves what is happening to current. We must ask ourselves what is happening to voltage. We must ask ourselves what is happening to resistance. So when you look at device X, we are given the voltage, which is 20 volts. We are also given the power in X, which is 100 watts. So it means we can get the R if we want by using the formula power is equals to V squared over R. And what is your power? We're given it's 100. And what is your V for X? Is 20. Don't forget to square it. And then what is your R? It's unknown. You solve for R. we're going to have 100R is equals to 400. You divide both sides by 100, then R is equals to 4 ohms. So now we know the value of R, which is 4 ohms. Then we look to the current. We can get the current of X and say current is equals to V over R. What is our V? Is 20. What is our R? It's 4. Then it means the current in X is equals to 5 amperes. You're done. The story is complete about X. You come to Y. We are saying as well for Y, we must know what is happening to resistance, must know what is happening to current, and you must know what is happening to voltage. We are just analyzing. We have not yet answered the question. We are playing. We are analyzing this thing. We are given the power for Y, which is 150 watts. Now, when you look at X and Y, they are connected in parallel. Then something must come to your mind. You will remember that, oh yes, we said that the potential difference for resistors connected in parallel is the same. So if an XV is 20 volts, what will be V at Y? It is going to be 20 volts because they are connected in parallel. So once we're having power, we're having V, we can strive to get I and say power is equals to VI. Power is equals to 20, and we know our power is 150 I. And then we divide both sides by 20. Then 150 divided by 20. Our answer will be 7.5 amperes. So now we know I will be 7.5 amperes. And then the learner will say, I can get R. Yes, you can get R if you want. And say R is equals to V over I. What is our V? 20. What is our I? 7.5. So what is going to be R at Y? Going to say 20 divided by 7.5, which will be 2.67 ohms. This is the information that you have. You're like, okay, now I've done everything this teacher has said to me, that this topic is about I, R, and V. Now, what do I do now? We are saying if you are given the EMF, your destination must be internal resistance. We can never rest up until we get our internal resistance. So, now what will happen? You look at X and Y. I'm not looking at the question. I'm analyzing. You look at X and Y. They are connected in parallel. What did we say about the current in parallel? We said that the current in parallel is divided. Therefore, for me to get I total, I must add the current at X and the current of Y. And then, what will be your current at X? Go back to the previous slide. It was 5 amperes. So current at X is 5 amperes. Plus the current at Y is 7.5 from the previous slide. And then you add them 5 plus 7.5. What will be your answer? 12.5 amperes. Now I'm having the total current. Yeah, I'm moving now. Then I'm like, I can get R external. I'm just analyzing. I'm not answering any question. I am analyzing. We can get R external and say, let's look at the connection of X and Y. They are connected in parallel. So we can say R external, Rp is equals to R1, R2 all over R1 plus R2. Our R of X, you go to the previous slide, it was 4 ohms. So it's 4 ohms. And then the R of Y, it was 2,67. All over 4 plus 2,67. Then what is your Rp? So we all perform the calculation. 4 times 2,67 divided by 4 plus 2,67. And then you'll get the answer. Resistor in parallel will be 1,60 ohms. Then you're like, okay, now I'm having I total, I'm having R external. Then now I can start with the formula. Remember our destination. If you are given the EMF, my destination should be internal resistance. We will not rest up until we find internal resistance. Then you will say EMF is equals to I plus I. Now, what is our EMF? We are given is 24. What is our I total? Calculated it 12,5. What is our R external? 1,60 plus 12,5. We don't know our R. 24 is equals to 12,5 multiplied by 1,6. I think it's 20 plus 12,5 R. Then you transpose 20 to the other side of the equal sign. 24 minus 20 is equals to 12,5 R. 4 is equals to 12,5 R. We are solving for R, right? We divide both sides by 12,5. 12,5. These ones, they cancel each other. And then our R will be 0,32. 0,32. So now once you reach this destination, then you can start to celebrate and look at the question. The first question is saying calculate the current in X is somewhere there. The second question is saying calculate the resistance in Y is somewhere there. The next question is saying calculate the internal resistance of the battery is somewhere there. So for us to pass this topic, let's analyze. The topic is about 3 things: the potential difference, the current, and the resistance. So if we analyze properly, we get all the calculations. The examiner will ask about your analysis. Then we are sorted. Then we are sorted. What more do you want? What more do you want? Now, let's come to the second activity. We apply the same thing. For every resistor, we must know what is happening to current. We must know what is happening to potential difference. Here is our issue. A circuit diagram shows a battery with an EMF of 60 volts. Once you are given the EMF, you know your destination. Whatever that we do, we must get the internal resistance. And an unknown resistance are connected to 3 resistors. You are told that this voltmeter reads 21,84 volts. And that's it. We don't go to questions. We analyze. We want to know. We analyze. Our destination is the internal resistance. Now let's start with our story. When you look at this connection, we are seeing a series parallel network. I told you. The first thing that you come across when you look at the circuit diagram, it is the connection of the resistors. 2 resistors, they are connected in parallel and 1 is in series. So this is a series parallel network. Now, for this 8 ohm resistor, We now have R, which is 8 ohm. We now have V, which is 21,84. We can get I, which is the current. Then you can say I is equals to V over R. What is your V? 21,84. What is your R? 8. Then what will be your answer? 21,84 divided by 8 ohm resistor. Then you'll get your answer as 2,73 amperes. So this is the total current. This is the total current. Remember we said the current that flows in series is the total current. So this is the total current. So already you must celebrate to say we are having a total current. Once we have the total current, our job becomes easy. We must get R external. We don't need now to do these other things. We just need to focus on getting R external. We are strategic now. For us to get R external, two resistors, they are connected in parallel. So Rp is equals to R1, R2 all over R1 plus R2. 30 multiplied by 20 over 30 plus 20. So 30 multiplied by 20 over 30 plus 20. I think our answer is 12. So our answer will be 12. But these are the resistors in parallel. We want R external. We want R. So for us to get R external, we'll say resistor in series plus resistor in parallel. The one in series is 8 plus the one in parallel, which is 12. So our R external will be 20 ohms. Then we can start now to be obsessed to get the internal resistance and say EMF is equals to I plus I. What is our EMF? 60. What is our total current? 2,73 multiplied by R external, which is 20 plus 2,73 R. Now we perform our maths. 2,73 times 20. What will be your answer? It will be 54,6. So here we have 60 plus 2,73 R. You transpose 54,6. You'll have 60 minus 54,6 is equal to 2,73 R. And then I think here you'll get 5,4 is equals to 2,73 R. Divide both sides by 2,73. Therefore, what is our R? It is going to be 1,98 ohms. So now we have our R. Right. Then now you can start to look at the questions. We have analyzed. The question is saying calculate current in what? Is somewhere there. Just extract it. Second question, equivalent resistance in parallel is somewhere there. Another one, internal resistance of the battery is somewhere there. What more do you want? What more do you want? So the power of calculations in electric circuits, it is for us to have effective analysis of the circuit diagram. The last question, heat dissipation in the external circuit in 0,2 seconds. Then you can say W, if you like. You can use I squared R multiplied by change in time. Now let's deal with it. 2,73 squared, 2,73 squared multiplied by 20 multiplied by 0.2. Then our answer will be 29.81 joules. And there are different ways of getting this. Then you have total. Total. And where does this total come from? Confidence. Confidence. Then I'm going to allow you to engage with this question for roughly 10 minutes, and then we discuss the feedback. It's an interesting question. All the best. Now, let's look at the feedback. A battery is connected in a circuit diagram as shown in the diagram below. When switch S1 is open, the current does not flow and the voltmeter reads 22.14. This is the EMF. Once you have the EMF, you'll be asked for the internal resistance. Then, write down the term that describes the voltmeter reading when switch S1 is open. You can see that these answers, they come out on their own. And the answer will be EMF. 9.2. When both switches are closed, the voltmeter reading decreases to 21.24 volts. What is this one? It is V load. And the current reads 4.5 amperes. Let's look at where the ammeter is. The ammeter is in series, so this is the total current. So with this information, you can attempt to answer the first question. Calculate the internal resistance of the battery. And you can say EMF is equals to V load plus V lost or V internal. What is your EMF? 22.14. What is your V load? 21.24 plus IR, which is 22.14 minus 21.24. If you transpose it, you'll be left with 4.5 R. Then 22.14 minus 21.24, your answer will be 0.9 is equals to 4.5 R. We divide both sides by 4.5. Therefore, our R will be equals to 0.9 divided by 4.5. And our answer will be 0.2 ohms. So for this 9.2.2, we are going to start by focusing on this 4 ohm resistor. So for this 4 ohm resistor, we have the value of R, which is 4 ohm. We have the value of current, because it's flowing in series, it's going to be the same, is 4.5 amperes. We can get V. We can get V. So we can say I or R is equals to V over I. What is our R? Is the 4 ohm resistor in series. What is our V in series? We don't know. And then what is our current in series is 4.5. Then V will be 4 times 4.5. And what will be your V in series? 4 times 4.5. And then our V in series will be 18 volts. Then, once we are having this 18 volts in series, we know that for us to get R external or V external, for us to get V external, we must add V in series plus V in parallel. So already we know what is our V external. We are told it is 21,24 volts. So it is 21,24. V in series is 18. So now we want V in parallel. Then you transpose 18. It becomes minus 18 on the other side. Then we'll have 21,24 minus 18 is equals to V parallel. And V parallel will be equals to 3,24 volts. Now once we have V parallel, you must remember we said the potential difference for resistors connected in parallel is the same. So the potential difference is the same for all the resistors connected in parallel. Therefore, we can say R parallel is equals to V parallel all over I total. Our V parallel is 3,24 all over 4,5. So 3,24 divided by 4,5. And then our answer is going to be 0,72 ohms. So that's our resistor in parallel. Now, as we move on, and also maybe we need to look at the mark allocation to say this one gives you 1, 2, this one you have 3, 4, 5, 6. We can't mark this one because we have marked it already. So it's 6 marks. Then let's continue. Then they are saying, looking at the very same circuit diagram, name one factor that can cause the reading to change. You go to Ohm's law. It says at constant what? At constant temperature. So one thing can change here. It should be temperature. You get 1 mark for that. Now switches 2 is open. Will the voltmeter increase, decrease, or stay the same? If both S1 and 2 now they're open, the voltmeter reading will increase. That's our correct answer. Then this is your homework. Here is your homework. And make sure that you discuss it with your friends and deliberate on answers. Your homework continues. You can see your homework continues. Then from our next lesson, we'll start by providing feedback for the homework that I've given you. Let us make sure that we use this revision to thoroughly prepare ourselves for prelim and final exam. Let us have group or peer collaborative revision where we form small groups and we teach each other the content. This time is no longer about the educator. This time it's about you as the learner. Now you must recitate the knowledge that you have been given from term 1, term 2, term 3. So let's use this revision program to make sure that we are thoroughly prepared for the upcoming examination. I will close with a quote of Nelson Mandela. Because the reason why we are doing physical sciences, it is because we are the future. And it is us who are going to provide scientific solutions to all the challenges that the world faces. So it is in your hands, young people, to create a better world for all who live in it. Trust is with you. We wish you well. See you next time. Bye-bye.